All right, second page. These are a little bit more challenging, but they're still totally doable for you. So this is a regular pentagon. And if you check on your chart, since it is regular, that means, of course, all of the sides are equal, and all the angles are equal. And we're looking for this angle right here. Well, if that's the case, I know for sure that an angle here is going to be 108 degrees from my table, or from doing the 5 minus 2 times 180 divided by 5. That would get us each individual angle here. And there's a bunch of ways to do this, so I'm just going to show you one. Y'all see this lovely shape right here? That is a trapezoid that has two equal sides, so it's an isosceles trapezoid, which means that this angle and this angle will add up to 180 degrees. So if this is 108, this is going to be a 72 degree angle, as is this one. And knowing that this is 72, these two together, right, this one and this one would add up to 108. And that would lead me to know that this angle right here is 36, which also means that this one is 36. And then I can add those together, 36 plus 36. Check it out, that's also 72 degrees. And then we can use this lovely triangle and say this angle plus this angle plus this angle will sum to 180 degrees. So 180 minus 72 will get you that this is actually also 108 degrees. And knowing that the answer here is 108 and that these are all 108, see if there's another way for you to figure that out. So that's the first problem. Second one on the back, we've got a regular pentagon is constructed from the midpoint of the side. So midpoint means that this guy right here is going to be halfway between those two things. And then I also want to point out, since this is a regular pentagon, that all of the sides here are also going to be equal to that, which is going to come real important because then this triangle right here is going to be an isosceles triangle. We just saw, if you can see this kind of on this one over here, that this would be a 36 degree angle with that one line drawn in there on the pentagon. You'll see how this line and this line are basically the same thing. So if you did number 5, you can just carry that knowledge over here and know that this is a 36 degree angle and this is a 72 degree angle. Just throwing that out there. We also know, because it's a pentagon, that that's a 108, which means this one is also going to be a 72 degree angle. And then all of a sudden you're in kind of a nice spot, because this triangle right here is isosceles. So we know that these two angles are going to end up being the same angle, that angle right there and that angle right there. And so you do 108 180, geez, too many numbers. 180 minus 72 would get you 108 degrees. And then you can split that, I can write numbers, 108 over 2, and you'd get 54. So each of these blue angles are going to be 54 degrees. And then what the problem is asking for is this whole angle right here, which is just going to be the sum of 54 and 72. So you can say 54 plus 72 would get us, there's going to be a 6 at the end of that, and 7 and 5 would get us 126. That is the answer for that problem. There's other ways that you can do that too, so it doesn't have to be that way. Okay, this one requires that you just do a lot of noticing. Since this is the central point from the center point of a square, I'm going to extend this line out down here. And we know that this is, again, a regular pentagon, which means all of those sides are the same. But if you also notice in a square, the central point, this is going to be a midpoint of that diagonal. So this is also going to be the same. And what we're going to get from that is that we have this lovely isosceles triangle that we can make use of. since we have, again, our lovely regular pentagon, I know that this is going to be a 108-degree angle, and this right here is going to be 72. That gives us, just like that last problem, that these two angles right here are going to be equal, and they're each going to be 54 degrees. And we know, again, same shape that we had before, this quadrilateral right here is going to be a parallelogram, because that line and that line are going to be parallel. So I know that this angle and this angle are going to add up to 180, so I know this is 72. And again, we've got 72 plus 54 is 126 degrees. Here we have regular hexagon and regular octagon. So I'm going to first make note of the fact that in an octagon, each angle is going to be 135, and in a hexagon, each angle is going to be 120, which is going to come in handy for us. And the way that I saw this first, which this works for me, maybe will not work for you, not totally sure. There's this lovely shape here that is a 1, 2, 3, 4, 5, 6-sided shape. So it is a hexagon. It is also symmetric, so like this angle and this angle are going to be the same. This big angle here and this big angle here are going to be the same, as is this little one and this little one. And what I'm doing right now is I'm trying to get this little one because I'm feeling very confident just the way that the octagon is created, that this is a 90-degree angle. So really what I'm trying to do is I'm trying to find that little one right there. Well, here's a 135. And here's a 120 from 360 minus 135 minus 120. I get that this purple angle right in there is going to be a 105-degree angle, because you get 105 here. So this red angle, which is the same as this one right here, is going to be 225 degrees. So my 120, I got two 120s, one here and one here. I got two 225s, so I've got 2 times 120 plus 2 times 225 is 690 degrees. And any hexagon has 720 degrees all total. So I do 720 minus 690, and I will find out that I am missing 30 degrees. And that means that this little angle here and that little angle here are going to split that 30. So I'm going to say 30 divided by 2 is 15 degrees. And thus, my missing purple angle here, that one right there is going to be 15. This one is going to be 90. And so I'm going to say 90 plus 15 is 105 degrees.